Process of long division of polynomials is exactly the same as the process for long division of numbers. You divide, you multiply, you subtract, you bring down the next thing. All right, so we're going to do long division of polynomials. And we'll start out with a simple example like this. Now this problem, we could go back to our monomial expressions or simplifying or dividing, simplifying polynomials from test 1 or test 2. We did some things like this. We didn't show the long division process, but if I did 2xy squared divided into 4x cubed y to the 4th plus 6x squared y to the 5th minus 12x cubed y cubed. Sorry, my cubes there don't look like cubes. The process is the same. 2x squared divided into this, and you can even come over to the side. What is 4x cubed y to the 4th divided by 2xy squared? What do you get?
2x squared.
2x squared y squared, that's correct. 2x squared y squared. The next step in the process is multiply. That gives us 4x cubed y to the 4th. Subtract. And then bring down the next term, 6x squared y to the 5th. All right, now I'm going to kind of rush through this process because 2x squared y squared now divides into this, plus 3x y cubed, right? And if you multiply that, you get 6x squared y to the 5th. And then we will subtract and bring down the next term, negative 12x cubed y cubed. And then this will divide into this, negative 6x y squared times. And no, x squared y squared times. And then when you multiply, you're going to get that. Now, you're not going to have a lot of problems like this, a monomial divided into a polynomial, because
It would just be y.
yeah, you're right. It's just y first. Thank you. Good. Is that the best way to do this problem? Do what? It's not, is it? What's the best way to do this problem? Split it. That's right. Splitting a fraction. If you have, so this is the same thing, guys, as each of these terms over 2xy squared. But isn't that what we just did? We divided each term by 2xy squared. And we could even do that mentally, I think, for the most part. So the easiest thing to do is to divide each term by 2xy squared. If you divide them individually by 2xy squared, you're going to get what we just got using the long division process. So long division process isn't really necessary in this problem. Can't do that. It's not really necessary in this problem, but let's show the long division process to work this one. X squared plus 4x minus 5 divided by x minus 1. What? And there's a quick way to do this one too, but I want to practice the process of long division. So we can do, let's just show the long division process. X minus 1 is going to divide into x squared plus 4x minus 5. You could also simplify this one by factoring. All right, but let's do the long division process. And the long division process involves dividing, multiplying, subtracting, bringing down the next term. So we're going to repeat that process over and over until we're done. So we have to see how many times x will divide into x squared. And if you'd like to come off to the side, you can, and actually do that division. X squared divided by x is what? x, right? So it'll go into it x times. Next step in the long division process is to multiply. X times x minus 1, and that'll give us what? X squared minus 1x. And then the next step in the long division process is to subtract. Right? Now subtraction is going to change the signs. Right? So that's going to become negative x squared and positive 1x. That's what the subtraction does. Subtraction changes the signs of our polynomial expressions. So when we combine those terms, we're going to get x squared minus x squared is gone. 4x minus negative 1x is 5x. And then bring down the next term, and the process continues. Right? 5x divided by x is 5. Right? So that'll be plus 5. The next step in the process is to multiply. 5 times x minus 1 is 5x minus 5. And when we subtract those, everything goes away and we have a nice little 0 remainder. So x minus 1 goes into x squared plus 4x minus 5, x plus 5 times. All right? Now, this is an example of another one that you could do a little differently, right? The way we've done this previously, I think test 3, x squared plus 4x minus 5 divided by x minus 1. We could show it that way. And then you can factor the numerator as x plus 5 times x minus 1, and that would be over x minus 1. The x minus 1's cancel, and you're left with x plus 5. So there's another way to do the solution to that one, because we get a nice denominator going on, or excuse me, a nice factorable expression. This one, however, will not be that way. What was your question, buddy?
I was wondering, when you were doing opposite side, like x squared divided by x equals x, why would you only divide the part in the divisor by x and just ignore the negative 1?
Okay, because this is the term that we're trying to eliminate. So as we do our division, we're trying to eliminate this first term every time. Next thing, we need to get rid of this. So the next thing will come down and there won't be anything left. All right, so when you're doing a binomial divided into something, you're always just concentrating on getting rid of one thing. Because if you can get rid of that one thing, then you've got the next power to come up. Right? Because that's an excellent question. Because we know that, first of all, that our answer is going to be a first degree polynomial, because I have x divided into x squared. So those kind of drive the ship. So we need to eliminate one term at a time. So we eliminate the x squared, and next we'll eliminate that one. And then if there's more terms, like in this next example, we're going to eliminate those one at a time.
So why don't you just do anything with the negative 1? Like you only divide x squared by...
Yeah, we do something with a negative 1. When we multiply by x, and we multiply by negative 1.
When you divide them, how come you just only use...
Because I need to eliminate this term only.
You can only use the x to do that?
Yep.
Okay.
Yep. The negative 1 is going to line up with this term, and that's going to give me that term next, and then I have to get rid of that term by dividing x into 5x.
Okay.
So at one time, the rest of it just kind of comes along as, collateral, not damage, but stuff. All right. Now we're dividing x cubed minus 3x squared plus 4x plus 6 by x plus 2. Why is that division?
Because it has a negative 1.
Because this negative 1 exponent is equivalent to saying that this whole term is moved underneath as x plus 2 to the positive 1, right? And so it's equivalent to writing x cubed minus 3x squared plus 4x plus 6 divided by x plus 2. So this is just a clever way, or maybe not clever. This is another way to write long division, or divided by, the operation of division. We're going to use the long division process. Now, pretty sure that you're not going to come up with an easy alternative to some type of polynomial division. The first two problems we had workarounds. This one we're going to have to use division. Long division, or what we'll look at tomorrow, synthetic division of polynomials. You'll have to use one of those two methods to make this happen. So we're dividing x plus 2 into x cubed minus 3x squared plus 4x plus 6. And we'll start by dividing x into x cubed. How many times will x go into x cubed? It's x squared, right? If you needed to come over to the side and do that, x cubed divided by x is x squared. So that's where that quantity comes from. X cubed divided by x is x squared. The next step in the long division process is to multiply x squared times x plus 2, and that gives us x cubed plus 2x squared. Right? Does everybody see where that's coming from? X squared times x is x cubed. X squared times 2 is that. Next step in the process is to subtract, so that's going to make that negative and that negative. X cubed minus x cubed is gone. Negative 3x squared minus 2x squared is going to give us what? Negative 5x squared. So when you subtract, it changes those signs. And then the next step in the process is to bring that down the 4x squared. 4x, sorry. Now, x divides into negative 5x squared how many times? Negative 5x, right? X divides into negative 5x squared, negative 5x times. And we're going to distribute here. We're going to have to be really careful to make sure that we are mindful of our signs. I have negative 5x. So when I multiply negative 5x times x plus 2, that gives me negative 5x squared minus 10x. Subtracting that now is going to change both of those to positives, right? So when you subtract that, it's going to be plus 5x squared and plus 10x. So 4x plus 10x is 14x. Then bring down the next term, which is a plus 6. We're almost done. See now how we're kind of chipping away at each term. We're eliminating this leading term each time, so we're coming down to something that finally is just going to be a linear term. So I've got an x squared and an x to the first and then a constant, which is going to be what? How many times will x go into 14x? 14 times, right? So 14 times, distribute, that gives us 14x plus 28. And then we're going to subtract those. And that's going to give us 6 minus 28, which is negative 22. And what do we do with the remainder? Goes over the divisor, right? So it'll be negative 22 over x plus 2. And so that's the quotient here. Now on Tuesday, we'll look at a different method for doing problems like this. All right, there is a shortcut method of sorts. But there's some dangers in that shortcut, as always. It's like a lot of you insisted on using circle slide divide still on this last test, and it killed you. It's not a good method. There's just so many dangers in using it. Synthetic division, which is a lot shorter than this and a lot quicker, there's some dangers that we'll point out when we look at synthetic division. And there's some times where you just can't use it. It doesn't work. But we'll use it quite a bit in this unit that's coming up. All right? Write this one down. So this is x to the fourth plus 5x cubed minus 8x plus 10 divided by x plus 1. All right? I don't want to do that. I want to go back. X to the fourth plus 5x cubed. I'm making a mistake here, but because I want to make a point. we're dividing that by x plus 1. Okay? X goes into, y'all don't write this down because we're like, well, you can. We can correct it together, but don't work ahead of me. X divides into x to the fourth how many times? X cubed, right? So this will be x cubed. And then we distribute x cubed times x plus 1. That gives us x to the fourth plus 1x cubed, right? And then we're going to subtract. And that gives us 4x cubed minus 8x. Right? Now, x goes into 4x cubed plus 4x squared, right? And then when we distribute there, 4x squared times x plus 1 is 4x cubed plus 4x squared. And we got a problem there, don't we? What's our problem? Negative 8x and 4x squared are not like terms. Okay? And that's where the mistake, and I told you guys I was making a mistake. Anytime you have a missing power, like we go from x to the fourth, right? X to the fourth to x cubed. We're missing an x squared. We still need to have a placeholder for x squared terms. All right. Now, the equivalent of that, so really what we have to do here is plus 0x squared minus 8x. What was the final term? Plus 10. We have to have that. So we have a placeholder here. All right. Now, the equivalent of that is in our bell work problem here, or warm-up problem. What is the value of this 0 in this number? So how many hundreds are there? 0. So what's the value of this place? If there's 0 hundreds, that means that 0 has no value. Just like this 0x squared has no value in this number. Right? So this is not a foreign concept. It's something that we're used to doing with our regular numbers. We just don't recognize that we're doing it. You've got to have that placeholder there. How many x squareds do we have? 0x squareds. Right? So then we will finish the process. Right? So we'll subtract these. I'm going to have to write smaller. I'm going to run out of space here. That's negative 4x squared. Bring down the negative 8x. X divides into negative 4x squared, negative 4x times. Distribute, that gives us negative 4x squared minus 4x. Next step is to subtract, which changes the signs. Plus and plus. Negative 8x plus 4x is negative 4x. Bring down the plus 10. X divides into negative 4x, negative 4 times. Distribute there, and that gives us negative 4x minus 4. When we change those signs, we end up with a remainder of 14. And the remainder goes over x plus 1. Okay, so what's the moral of the story here? Yeah. You got to make sure that you have every power of x represented. You have to have placeholders for your 0 powers. Now, I'm telling you ahead of time, in the synthetic division process, you won't run into this contradiction. Remember, we had a contradiction right here. We had an x term and an x squared term. You won't see that using synthetic division. So if you forget the 0 at the beginning of the problem in a synthetic division problem, you're going to work it through. You're not going to know that you missed it. You just miss it. So that's one of the dangers of the shortcut that we'll learn on Tuesday. Synthetic division doesn't show us the missed 0 placeholder because we just use coefficients to do synthetic division. no powers of x. Okay, so let me run through this real quickly. This is what we just did. You got to make sure that every power of x is represented in your solution or in your problem. That's inside or outside. If we were dividing by something that was missing a power of x, we need to add it. All right, let's have a look at this one. This is one of those problems that you could use synthetic division to do it, but it's not the best way to do it. There's some issues. Fractions and common denominators and things like that will come into play. It's better to use long division. So we'll write this as 2x plus 3 divided into, are we missing any powers of x? We're not missing any powers there, so we can kind of roll right through. Y'all remembering this process now a little better? 2x divides into 2x cubed how many times? X squared, right? Distribute x squared times 2x plus 3, and what does that give us? 2x squared plus, no, excuse me, 2x cubed plus 3x squared. Then you subtract those. That'll give you 11x squared minus 3x squared, which is 8x squared. Bring down to plus 18x. Everybody with us? Most of y'all are working ahead. 2x divides into 8x squared 4x times. 4x times 8x squared, excuse me, 4x times 2x plus 3 is 8x squared plus 12x. Subtract. Now that subtraction sign is where people miss these problems. You forget to change the signs. 8x squared minus 8x squared is gone. 18x minus positive 12x is 6x. Bring down to plus 9. And this will give us 2x divides into 6x 3 times. And that will give us 6x plus 9. This one has no remainder. And that means that 2x plus 3 is a factor of 2x cubed plus 11x squared plus 18x plus 9. It divides it evenly. All right? One more, and then we're going to give you something to work on, and we'll finish the test. X to the fourth plus x cubed minus 17x squared plus 11x plus 5. And this time we're dividing by a trinomial instead of a binomial. All right? Now, in this case, guys, this is one of those things where you have to be careful. This example doesn't do this, but some of your homework problems will. If we're missing a power of x in the numerator, we need it. Right? But we're not, right? We got x to the fourth, x to the third, x squared, x to the first, and then x to the 0. In the denominator, if we have an x squared, then we would need if we're missing this term, we would need to put 0x there. Right? You need to have every power of x represented in your divisor and in your dividend. So x to the fourth plus x cubed minus 17x squared is being divided by that. Same game here, Noah. We're just trying to chip away one term at a time. So the first term we're going to deal with is the x to the fourth. X squared divides into x to the fourth, x squared times. Right? Then you distribute, subtract. That's going to change all those signs, so you need to be careful. X to the fourth minus x to the fourth is gone. X cubed minus negative 3x cubed is 4x cubed. Negative 17x squared minus negative x squared is negative 16x squared, and bring down the 11x. That's really, I prefer changing those signs instead of writing this becomes negative, this becomes positive, and this becomes positive. Actually change the signs, right? So you don't miss that deal. All right, x squared divides into 4x cubed, 4x squared times, 4x times. Distribute. All right, and we'll subtract again, which is going to make this negative, make this positive, and make this positive. So we'll have negative 4x squared plus 15x. Bring down to plus 5. Now x squared divides into negative 4x squared. Negative 4 times. We distribute there. You got to be careful. We're distributing a negative. So that's going to be negative 4x squared plus 12x plus 4. And when we change those signs, that's going to give us 3x plus 1 as our remainder. And what does the remainder do? It goes over the divisor. Okay? Now, guys, I want to kind of show you a little bit of a preview of what a homework problem might look like. We might be dividing a homework problem that looks like this. X to the 4th minus 1 divided by x squared minus 1. How would we set that up? X to the 4th plus 0x cubed plus 0x squared plus 0x minus 1 divided by x squared plus 0x minus 1. So when you multiply this thing, you're going to end up getting some blanks and bringing some things down. But if you keep all your like powers lined up, you're going to be okay. All right, so get started working on these problems.